Yeah, I can introduce our speaker, Bradley Simpson. Bradley Simpson is going to give us a talk called Introduction to Woody Plant Identification, which is, more than trees, more than just trees. And Tom McCoy recommended Bradley Simpson. I think maybe Tom can say more, but I think that he took a class uh, of his. But Bradley is the habitat manager for Nature Forward. So where our mycologist Serenella used to be, Serenella Linares, and Bradley manages that 30-acre woodland at their headquarters in Chevy Chase. He also is a graduate of UMD College Park, where he studied environmental science and policy with a concentration in wildlife ecology and habitat management. He's done research and active management of urban forests, and even in New York City, which I think is really interesting, and has categorized thousands of plants in the process in New York and at Wood End. So he's currently managing the restoration of Wood End's natural habitats, the forest area, and he does a lot of educational programs there, and is working on a master's in plant science from UMD, to even go deeper into urban forest ecology. So really excited to have Bradley, and also for him to be able to lead our members on a walk at Wood End, which I believe is August 24th. So that, if you're able to go, that will be a really nice way to link this talk, with nature. So anyway, Bradley, welcome, and thank you so much.
Well, thank you for the introduction. So I'll go ahead and say that it is an introduction to Woody Plant ID, and the fact that I'll be giving everyone a baseline of terminology and some taxonomy that really will help you learn and see the trees differently and the woody plants differently. But I'll apply this terminology to a few examples that are primarily focused on trees. But then when we do the walk at Wood End Sanctuary, we'll kind of just see what we see, and just identify whatever seems interesting. So I love hearing taxonomy, even if I don't understand the taxonomy of fungi. I love hearing the scientific names of our species, because it really does have a deeper connection to our local fauna and flora. And I know fungi is kind of like the in-between. But I like to focus on taxonomy. So when I introduce plants, I will mention the family that they're in, because these family relationships will have consistent characteristics that will help with kind of understanding just what you're seeing out in the forest. So I don't really focus on anything above the family level. I like this bottom triangle here, but I'll go ahead and I'll use a lot of the Latin names, and I was also hearing a lot of terminology throughout, and I feel like the terminology is pretty similar with fungal identification, that the root of the words that we learn have lots of Latin or Greek roots in it. So you'll hear a lot of those roots, but in different ways, as we figure out how those words are applied to our woody plants. But typically, the identifying trees, I use a key every day, a dichotomous key, which is a series of pair choices. I'm sure that and identifying fungi, there's use of lots of keys that help you get to an identification. These keys, of course, use characteristic features that help you with your identification. And of course, there's apps as well. Virginia Tech Dendrology has their own app that's really great. And of course, iNaturalist. The Tree Finder is a nice little pocket-sized book that's very easy to use and great for learning. It's only like $5-6. I get really anywhere. If you come to the Walk at Wood End on that Saturday, you can get your own at our bookshop. It's a great first key to use to figure out the common trees of our area, and then you can move into other keys if you're really curious. So these are just mentioning of other keys that I like to use when I teach my classes. I start with the Tree Finder. My next level up is the Common Native Trees of Virginia. It includes a little bit more species and more specific to our area, whereas the Tree Finder is more inclusive of plants in the eastern U.S., not including like Florida. And then the Muncher's Keys of Woody Plants is the big one. If you want to know what woody plant you have anywhere you are east of the Mississippi, whether you're in an arboretum someone's yard or in a forest. This one has it, but there are no pictures, and that's like the negative about it. Lots of complicated words, but it's really fun to use. Other things you always need are hand lens, ruler, knife and pruner, or binoculars. Sometimes you have to look inside, and trees are tall. Sometimes you have to use binoculars to really get a good sense of the leaf structure from down on the ground. There's just a nice little list of terms. There's a whole book just on plant identification terminology. It is its own language. You really can talk about plants without even using like any words we typically use in our day to day. And I wanted to show one of those terms, glaucus. I know it's not going to play for some reason, except if I zoom out. This is a glaucus underside of a red maple leaf. So it has this bluish white waxy coating, which can be easily rubbed off. And that's what the term glaucus refers to. So when you look to identify a tree and it has leaves on it, even without leaves, their first question that's always going to be asked is about leaf arrangement. There are three options. There are alternate leaves, where leaves occur singly along the stem, one at a time. There are opposite leaves that occur in pairs at each time. And then whorled refers to three or more at a time. There's only one species of tree, or there's two species, but there's only one type of tree in our region that has whorled leaves. So it's leaves three at a time. At each point, the leaves occur. That's our catalpas. So if you have a whorled tree, nice and easy, it's a catalpa. If you have something that's opposite, you're also in luck. There are fewer choices. Most of our woody plants here are actually alternately arranged. So when we consider, if we see something that's opposite, we can use, doesn't look good. I'm not sure why it's, there we go. That looks better. Matavijlani, a nice little phrase to remember what our commonly oppositely arranged species are. The mad referring to the maple, ashes, and dogwoods. Vives are for viburnums. And the Lani refers to the genus name for honeysuckle, Lonicera. So here's our honeysuckle here with opposite leaves, a red maple with opposite leaves, and dogwoods also with opposite leaves. And then if you know your families, you can actually lump in some other woody plants into these associations. Like maples are in the same family as our buckeyes and horse chestnuts, so the Aesculus genus, and the Sapondaceae. And then our elderberries here are in the same family as our viburnum. So, these closely related genera can be kind of associated together with this more simple phrase that can help us remember our oppositely arranged species. So twigs, these refer primarily to winter features, but these features can also be used during summer. Primarily, we see bud typically all year round. The only time we don't see buds is right after they open in spring. The stem and the leaves are making new buds. So after the buds open, you don't have any bud characteristics to look at, but those will mature throughout the summer and get ready to have the stored energy to be able to open next spring. So in our buds, we have those at the end, the terminal or apical bud. And along the side, we have axillary or lateral buds. When a leaf falls, it leaves a leaf scar. Where leaves occur, it's at a little thing called a node. And those are the most important terms for our twigs. And just really showing the difference between apical or terminal, only at the tip. The axillary or lateral is along the side, and they're growing in this axil. This is an angle between the leaf and the stem. Just to show that again, a little angle between a leaf and a stem. So this is an axil, which means this bud is axillary. We also have some other types of buds too. Yes, I will be discussing compound leaves when I get to the leaf section. I have lots of leaf characteristics. and showing where the bud occurs is very important when you're determining a difference between a simple leaf, which is just one leaf blade, and a compound leaf, which is a leaf that's separated into multiple leaflets. And we'll get to that in just a few slides. So our flower bud versus our leaf bud, our flower buds tend to be quite large. They're much more conspicuous. So on this stem here, we see really large flower buds. And then leaf buds typically are pointed and less significant, much smaller. But there are plenty of buds that include both the leaves and the flowers. If you think of the really large buds of horse chestnuts or the really pointed buds of beech trees, they have all of the growth in there necessary to, when they open in spring, to have new leaves, new stem, male flowers, female flowers, and those female flowers will produce fruit. And that's all on each really long bud that you don't want to run into with an open eye while walking through the forest. And when we look at our leaves, so we have seen some similar terms. We have apex, the top of the leaf. We have the margin of the leaf, what runs along the side. There are two types of veins, the secondary veins, the veins that come off the midrib, which is also called the primary vein. And the base of the leaf is those 5 terms make up the leaf blade. There's the leaf stem or petiole, and stipules. Sometimes they're just little baby leafy things that are closer to the stem. So simple versus compound. I don't know why this didn't copy over correctly. There we go. Simple versus compound. Simple leaves have one single leaf blade. Compound leaves are leaves that are separated into leaflets. So the question I always ask myself when I'm determining if a leaf is simple or compound is, where is the bud? So if I start at the top of the leaf here and I track down to the bottom to where I get to a bud, it's going to be right here. When I start at the top of the pinnately compound leaf, I start at the top and I keep going. I have to pass all these leaflets to get to my bud down here. There are no buds in between these little leaflets, since this is all one leaf structure. This is pinnately compound, pinnate like a feather. And then we also have palmately compound, like fingers coming out of a palm. So just the same way, we start at the top of the leaf and track down until we get to a bud. There's no bud over here. The bud is down here, defining this as one single leaf separated into 5 leaflets. So that is the simple versus pinnately compound and palmately compound. Of course, it's never that simple. You can have bipinnately compound leaves where your leaflets have leaflets. You can have tripinnately compound leaves, which your leaflets have leaflets. So it's really crazy how many times these leaves can be separated. Some popular plants that we see that are bipinnately compound, non-native mimosa tree with the really showy pink flowers that smell so amazing in the summer. Tripinnately compound leaves include our devil's walking stick, as well as a common landscaping plant, heavenly bamboo, or the nandinas. But there are lots of other leaf shapes that refer to really simple leaves or the characteristics of a leaflet. The ones I see a lot are ovate, leaves that are egg-shaped. But if a leaf is egg-shaped, but the wider part is towards the top, you put an OB in front of your term, and it's obovate, meaning it's the opposite of an egg. So the wider part is towards the top rather than towards the base. Then you have elliptic, really oval shaped or circular or orbicular. Those are the ones I use a lot, but you can see from this that there are many options for terms to be used describing leaf shape. Leaf bases and leaf apices, or the leaf apex, have their own terms. Of course, everything has its own term. It's never that easy. The ones I like to use a lot in the leaf anatomy for leaf bases are oblique when the bases are uneven, which is rounded, or cordate, nice and heart shaped. The leaf apex, I like the acuminate one. Acuminate is like if they took the tip of the leaf and they pinched it, and they pinch it to a point, and it just like has a nice long point to it. There's acute where it forms an acute angle. Obtuse, really like rounded or forming an obtuse angle, are the ones I use a lot. Venation, primarily we see pinnate venation. This is what we see on really all of our leaves. The other ones are quite characteristic to some species like the arcuate venation, where the secondary veins are curving back up towards the tip, are very identifiable of our dogwoods. Parallel veins are very identifiable of our monocots, and all of our monocots like grasses and orchids and palm trees, that these are different types of plants that aren't producing any true wood. So these are not technically woody plants, even though we do have palm trees within the group monocots. We have leaf margin terms, hairy margin for ciliate, rounded teeth, well, symmetrical teeth, or maybe those teeth are sawtooth, they're serrate. Maybe the teeth have teeth and it's doubly serrate. Lobed, I'm not sure why they use lobate, but lobed leaves like an oak. Lots of terms. And it's important to know something because the keys will refer to these terms. But luckily, a lot of these keys do have a little small glossary at the back that helps when you're trying to learn the features, or they have illustrations that help connect the features that's being described to an illustration. I've also just sent a PDF version of this PowerPoint to MAWDC so they can share it with you all, and I think a recording will be available online, because of course we're never going to remember all of these terms from one lecture. I want to mention too that leaves can be quite variable even on the same individual. For example, sun versus shade leaves are very variable in oak trees, where our shade leaves tend to be less lobed than our sun leaves, which tend to be more lobed. And this is to ensure that light is able to kind of go through the sun leaves and hit the shade leaves. It'd be really inefficient to have these large leaves at the top of the canopy that's blocking all the sun from the lower part of the canopy. So this really just allows the tree to increase its photosynthetic efficacy of the tree as a whole. We see this as very apparent from the northern red oak and the black oak, where you can see very large differences in leaf shape and size depending on where the leaf is on the tree. So I have some leaves here, and I was wondering if using the chat. Oh, so much variation in mulberry leaves as well. Is there a reason? I don't know. It seems to be quite random, and same with our native sassafras. I don't really see a pattern to the variably lobing. When I don't have a reasoning behind it, I do just like to say that one thing it does help with is its identification, even if I don't know the physiological reason for having these variably lobed leaves. I do tend to see the really lobed ones in higher amounts of sunlight, and same goes for like porcelain berry. Like porcelain berry vine will have its much more lobed leaves, like here in this tree, much more lobed leaves in areas of more sun and less lobed leaves in shade. So here's a leaf. I kind of already said that this one is nice and lobed. This one's a white oak, so we have rounded lobes. And I'll talk about the difference between our red oak group and our white oak group. But this is the white oak, Quercus alba. Our state tree of Maryland, and it has these really nice rounded lobes and deep lobing in the sun leaves and shallower in the shade leaves. But I wanted to see if we might be able to try out using some of our terms in the chat to describe our the leaves that are pictured. If anyone is so brave to try out some terminology. Otherwise, I'll give some hints to try to help out. But for this leaf, we have toothing. But the toothing term can be quite specific. So it is teeth. The leaf I would definitely describe here as ovate, egg-shaped in a shape. So the serrate margins is a really great term to use, but the serrate margin typically refers to the teeth curving upwards, like the teeth curving upwards. These teeth are more just pointed straight out. So these would be, right, Rick, these would be dentate, which actually refers nicely to the Latin name of this plant, Viburnum dentatum. I really appreciate whoever named the Latin names for viburnum because they are so helpful in telling you some identifying features, like the maple leaf viburnum, Viburnum acerifolium. The Latin name literally means maple-like leaf, or the black haw viburnum, Viburnum prunifolium, its species name literally meaning cherry-like leaf. I really appreciate them naming those trees based off of tree shrubs based off of how you would identify them. So another one, what are some terms that come to our mind when we see this leaf? Yeah, definitely cordate. That pinch tip is right. Palmately veined is another great one. We see multiple main veins coming out from one single point. They're all great. It is wired primarily towards the bottom. I think cordate would be a good word to use for the overall shape of the leaf. Smooth margin, which a term we can use for smooth margin is entire. And our pinch tip term that Alan that you mentioned is would be acuminate. Acuminate equals pinch tip. And then we have our smooth margin would be entire. Oh, I did that backwards than I did last time. So really great. I like being able to learn these terms and then try to apply them right away. And yes, exactly right. Who said it was redbud? Katie, this is redbud, Cercis canadensis, one of our nice legumes. Pretty pink flowers. The flowers are edible, make a nice little accent to a salad. But the fruits are not. Do not eat the fruits. But you may the flowers taste like a nice little green pea. All right, what about this one? These ones have some weird terms to be used. So it's not a sweet gum. Sweet gums are going to have more of a star shape, more consistent star shape. And we have some indented. Yes, a lobe, Katie. These are lobed leaves, so they are indented. But a sweet gum will have lobed leaves, and the leaves will be serrate. They'll be toothed and lobed at the same time. So yes, these are the tulip tree for not coming to a point at the top. Truncate when it's like cut off. I'm going to use like flattened / cut off for truncate. But this is a tulip poplar, but I like to make sure we are really learning our taxonomy. This is, I like to call it, just say tulip tree, Liriodendron tulipifera. I have found morel mushrooms at Wood End around our Wood End forest is primarily tulip tree since it's younger. Tulip trees are a very integral part of a forest in its early stages. So they are a fast-growing, sun-loving tree that forms the first closed canopy of our forest in the eastern U.S. And underneath the mature tulip trees, we have typically young oaks and hickories that are slowly growing in the shade, waiting for a tulip tree to fall to open up sunlight for the oaks and hickories to form the next canopy stage. And then a disturbance happens and it all starts over. So tulip trees are very important. I think we do only have just one single main vein. These, while coming out from a similar point, are not as large as the single vein in the middle. So I would still call it pinnately veined. I definitely like I'm biased because I like to do these drawings, but it definitely, I can never get this out of my head that has like this whole cat shape to it. But the tulip tree, and why I say tree, not poplar, the tulip tree is in the magnolia family, the Magnoliaceae. So it's a type of magnolia. They're in the Magnolia family. There are really only two genera, the Magnolia genus and Liriodendron. This genus, Liriodendron, only has two species in the world, our tulip tree here in the eastern US, and then the Chinese tulip tree in eastern Asia. And they have these really showy orange flowers. They're definitely reminiscent of a magnolia plant, whereas poplars are not as really showy. They do have very similar bark characteristics, but they're in the willow family and they're quite distantly related. Magnolia trees are much, much older taxonomically than our poplars are. And the tree is also a host plant for our eastern tiger swallowtail butterflies. So those are a lot of the vegetative features. I wanted to mention flowers. There are so many ways we can see flowers. I like the flowers that are just solitary, where it's just one flower occurring on a stem, and that's it. It's really nice and simple. But there are so many other ways flowers can appear off of a stem. They can be branched very conspicuously or many times. Really, they can be very unique, like the spadix and spathe. This is of our arums, like Jack in the Pulpit. Our umbels are very identifiable of our carrots, the heads of our asters. But what I really focus mostly on is our morosity, our number of petals, our flower parts. We have 5 here in our rose, 4 here in our dogwood. But if anyone knows, these are actually not true petals. These are our bracts. Our true little flowers here are not even open yet. I really didn't cross over well enough. And then oaks and hickories, the flower parts that litter our streets in the spring are catkins, these drooping clusters of really small flowers that you don't really see up close until they fall on your car and spread pollen everywhere. Perfect flowers are defined as having both the stamens, and the female part, the pistil flower, part of the flower in the exact same flower. There are many situations where we have perfect flowers, like in tulip tree, where each flower has the male and female. But there are many situations as well where we have separate male flowers entirely and separate female flowers. So the male flowers only have stamens with the pollen, and the female flowers only have pistils and will produce fruit. We also have differences where entire individuals of plants will be male or female, as in our hollies. So our tulip tree, here's our beautiful magnolia reminiscent flower of our tulip tree. It is monoecious, meaning a single house, that one tree has both the male and the female parts in one house or one individual. We have dioecious flower or plants, which means two house or double house. So one individual is male and another individual is female. So this is an example of our female flowers, which only has the larger green pistil here, and our male flowers on the male hollies having stamens. And then I showed the catkins already with the oaks. Here's some nice long catkins of the hickories. Fruits. Lots of different types of fruits. We have dry fruits that at maturity are dry. We have those that don't open on their own, like nuts, like the black walnut. We have dry fruits that do open when they are mature, like a legume. We have fleshy fruits, like drupes with a stone pit. Ooh. Haven't updated. Native serviceberry is a good example of an edible pome, actually. It's not a berry. A berry is like a blueberry, and the apple pome comes from a very specific part of the flower where the fleshy part of the fruit that we eat in an apple comes from a very specific flower part called a hypanthium, and it's like this fused structure that where the sepals, petals, and stamens all come from. It's very, very interesting. But native serviceberry is also just like a little mini apple. We have aggregate fruits where fruits are like clustered together, like a raspberry. And whenever you're eating a tomato, remember that it is a berry. It is a fruit with bunches of seeds in it. So very similar to a blueberry, you have a tomato. We have bunches of different types of acorn shapes and hickory nuts. But what I like to point out for the oaks is the difference between the red oak groups and the white oak groups. Our red oak groups acorns mature in just 2 growing seasons, 18 months, whereas our white oak group acorns mature in just 6 months. So from flower to a mature fruit in a white oak group, you have just 1 growing season. But on the red oak groups, you have 2 growing seasons to get a mature fruit, which means you have little baby acorns, little adorable baby acorns present on the stem in the winter of red oak group trees. So this is a willow oak. And you can notice they differ from a bud because they have the remnants of the female part of the flower. These are the styles and stigma that caught the pollen and allowed this fruit to develop and mature into a potential new tree. Very adorable. Bunches of bark types. There's a whole book on bark that defines like all the different types of bark that we have in our region. The bark book is specific to the trees of the Northeast, so there are some species of trees in Maryland that we won't see in the book, since Maryland has a nice mix of trees we see in the Northeast because we're at their southernmost range, and trees of the Southeast because we're at their northernmost range. So when leaves fall off and they leave leaf scars, you can get some interesting shapes. And even the bundle scars, which are the remnants of the vasculature, the veins and arteries of the tree, they can leave behind scars as well that can be identifiable, such as this conspicuous, like monkey-like face of a black walnut leaf scar. We'll look inside of our stems and see that they can be chambered like this walnut, where you have little gaps, or even the pith can be shaped like a star in our oaks. I'm gonna look inside the stems and see identifying features. On the bark too, we see lenticels that are gas exchange pores. They can either be raised and create their own shadow like spice bush, little horizontal ones in our cherries, or diamond shaped in our poplars. Lots of other thorns and protuberances coming off of trees. These are all based off of like where the structure comes from. So thorns are like basically stems. Spines are from modified leaves. Prickles are just an outgrowth of the epidermis. So roses have prickles, not thorns. So someone might have to rewrite a song. We have wings, which are thin flanges of tissue, and then warts like in our hackberry, a fern protuberance. And just show some others, a young honey locust, our prickles on our rose, paired spines on our black locust, and then our bristles, our hairiness on our wineberry. And if we look closely on our wineberry, we'll notice that the end of the hair, there's like a little spherical shape to it. It's a gland, which means you get bugs will get a nice little sugary substance from each of those hairs on the wineberry. So now I wanted just to take some time to go through some identifying features of our common trees here, using the terms we just learned. So if there's any questions throughout, please feel free to put in the chat and I will answer them. But northern red oak is one of our common red oak group trees. So red oak group tree.
Hey Bradley, I don't know if you can hear me, but I think you are frozen up, and maybe we've lost him entirely. We'll see if he makes it back. It's a bummer. We'll keep an eye on the list here. Here we go.
Bradley, you might still be muted.
Yep.
Unmute. Oh, that was interesting.
There you go. You're back. Excellent.
There it is. Okay. Don't know what happened. That was really strange. But nonetheless, our southern red oak has very long bristle-tipped lobes where that hair-like feature is very conspicuous. And honestly, I call this tree the middle finger oak because of the really long central lobe. But these are really only that feature is really only apparent in the sun leaves. The shade leaves don't have as long of a middle finger, but very hairy on the underside, very soft, really soft to the touch. And this uh, bark is very plated. These has like really small little plates on it, but it's still very dark in color. And here's that variety of shape you can see from shade, less shade, less shade, less shade, lots of sun. It's definitely always good to pay attention. I never recommend looking at one single leaf or one single feature on a tree. Always got to take a tree in as a whole. And thank you for those who are putting in associations with fungi, as I am very good with the tree identification, but not knowing the fungal relationships they have. So thank you so much for chiming in on those. Black oak, we have again another one with really huge difference of our large shade leaves that are barely lobed versus our really lobed sun leaves. These tend to have an orange texture, orange hairiness on the bottom of the leaf, and a very plated bark that's dark in color. Our scarlet oak, Quercus coccinea, is very similar to our northern red oak, but a really difference in the shape of the lobes, where our lobes form like a little C-shaped here compared to the U-shaped lobes of our northern red oak, which is such a minor characteristic difference. And the bark looks very similar as well. This is not as dark as our northern red oak picture I showed earlier, but there can be lots of variety. But you still have this streaking of darker gray and light gray. So very similar to our northern red and very closely related. And it said that the oaks can hybridize a lot as well. So you might have some genetics of two species showing in one individual. In our white oak group, of course, we have the little white oaks. This is what the leaves look like when they're first emerging. I just think they're so adorable. They start off red and they actually turn green as the chlorophyll is produced or is showing more. I'm not sure where my text went, but the bark is the flaky gray, really plated towards the bottom and like almost peeling off towards the top, and these small rounded lobes. Chestnut oaks are interesting because the leaves are not lobed like our other oaks that we typically or what we imagine with an oak leaf having a lobed leaf. Chestnut oak really breaks that rule, having these rounded teeth instead, and a bark that's really thick and furrowed. So furrowed having like these ridges, and I call them like valleys in between the ridges. Our post oak having a nice T shape to it, lowercase T shape, and they're very thick, very thick. not as thin as our other oak leaves. These leaves take forever to decompose in the soil. They have a very similar bark to our other white oak group trees, a light gray, plated towards the bottom, flaking towards the top. And here's these are like this year's leaves on a post oak, and this is last year's leaves, and you can see they have not even decomposed in the slightest. They're so thick. Pignut hickories, onto our hickories in the walnut family. Our pignuts are nice and easy. They are the hickory trees in our area that have 5 leaflets. So this is 1, 2, 3, 4, 5 leaflet on one leaf. So again, we start from the top and go down towards the bottom. We don't hit a bud until we're down here. So pignut hickory has the 5 leaflets pretty consistently. We can go into, it has a nice large terminal bud as common in our hickories. Mockernut hickory, Caria tomentosa, another Latin name that helps with ID, the tomentosa referring to the really hairy texture of the leaves. Tomentose meaning densely hairy. And these have typically 7 to 11 leaflets. 5 is very rare to see, and 7 is the most common, but up to 11 leaflets on one single leaf. Very hairy stems as well. And the bitternut hickory has a very similar number of leaflets to our mockernut, but not hairy at all. And the bud is very yellow sulfur-like bud. Our black walnut, Juglans nigra, known for its really, really dark bark, large leaf scars. And I always like to joke that large leaf scars are left by large leaves. When you look for characteristics of this tree in the winter, the leaflets have all decomposed because they're very thin and they readily decompose quickly. But we can see the rachis, which I'll show actually in our mockernut. This stem here, this is the rachis, where those are the leaf stem that the leaflets are coming off of. So walnuts have a very long rachis, which relates to the really their leaves having many leaflets, and the rachis doesn't decompose as quickly. So you can find these scattered on the ground in winter around black walnuts. Tulip trees, we talked about already a little bit, have the nice cat-shaped feature, long petioles, a duckbill-shaped bud. In the winter, we can see its fruits, its samaras hanging at the tops of the trees. And the bark is what gave it that poplar name. A really similar bark that we typically associate with our poplar trees. Red maples, opposite, nice and 3 lobes on it, but the leaves are not just lobed, they're also serrated along the edge. When I said the consistently 3 lobed is, sometimes you can see like a 5th lobe coming out of there at the bottom, but the 3 is what we see primarily. Nice red stems, really great bark. Sugar maple, it also will have 5 lobes, but consistently 5 lobed. And what I like to refer to as the sugar maple is that it has this nice square feature, and I compare that to like a sugar cube. So sugar cube, sugar maple, the square feature on the leaf. And the buds are much different in color. They're more pointed, and they're more like a dark brown to purple in color. And we're just at the southern part of its range. And we have plenty of these species at Woodend. I've even had the opportunity to tap some of them. I haven't made syrup, but I've done some tapping just to see if it was possible. I think, nope, Nora maple is not, I don't have it, but Nora maple will have consistently 7 lobes on the leaf, more so than the sugar maple, more lobes than sugar maple. And the best way to tell right now is when you pull a leaf off of the tree of a Norway maple, you'll see a milky white sap coming from the petiole, this milky white sap coming from the petiole. And I'm trying to find, and it will, and that differs from the sugar maple, which has a clear sap. You don't have a milky sap when you pull the leaf off. And typically on our Norway maples, you have 7 lobes, 1, 2, 3, 4, 5, 6. And this is hiding in the dark of the picture, but a 7th lobe down at the bottom. The Samaras are also 180 degrees from each other. So really wide spreading Samaras, which differs from our Acer saccharum, the sugar maple, which are not as large an angle from each other. But otherwise, the bark characteristics and the bud characteristics are quite similar between the two. Very similar. So the best way to tell the difference is when they are in leaf or even in fruit. So ashes and other opposite leaves, we have green ashes. So they have compound leaves as well. Typically 7 leaflets is what I see most commonly, but the leaves themselves are opposite leaves. The green ash is primarily found in the coastal plain in Piedmont, except you'll find it in some stream banks in the mountains. So like wetter habitats typically. The green ash also has a flatter bud top, like the leaf scar difference between the green ash and the white ash is like so minor, and honestly that's really difficult to tell apart the green ash and the white ash, but they actually don't overlap in habitat too much. Our white ash tends to be in the mountains and not as common in the Piedmont, and in the coastal plain you barely see any white ash. You'll primarily see green. Our American elms, well known for the really uneven leaf base and the doubly serrate leaf margin, the teeth having teeth. So you have big teeth with little teeth in between. I like the bark of the American elms because, especially on a young tree, because they kind of break our perception of what bark should feel like. Bark is typically, thought of as being a really hard structure, but the bark of American elms, if you like squeeze it, it's squishy, which is just really strange when you're feeling a tree. You don't expect a tree to be squishy. Slippery elms. I'm honestly not 100% sure what the slippery part refers to, but the leaves are much more rough than our American elms. American elm leaves are only rough on top, but not rough on the bottom of the leaf. Whereas our slippery elm leaves are rough on top and on the bottom of the leaf. And the slippery elms tend to be a little bit, have a hairier new growth of the stem, but the bark characteristics are quite similar. Thank you for chiming in on what the slippery refers to. Some persimmons, nice, delicious fruits. And remember then persimmons is another example of our dioecious tree. So we only get that fruit from our female individuals. But otherwise, I feel like the leaf features, there's nothing that like pops out as identifiable. Very typical leaf shape, entire margins, really smooth. But the identifying features is bark. Very, very plated. That plated feature even appearing when young and showing off the orange color of the inner bark in between. Black locust with its sharp spine. So these are modified leaves. Even though they're modified leaves, they're still very sharp and they do hurt. But they have a nice compound leaf with these rounded leaflets and these really thick furrows. And those spines can even be present on older stems. And I know there's a particular shelf fungus that is associated with the black locust. And if you come to Woodend, we have plenty of mature black locust with that shelf fungus present. I don't know the name of the shelf fungus.
I think it's like Solinus robinii, but now it might be like, well, they might have changed the genus, but it's robinii because I think that refers to the locust part, right?
Yeah, so Robinia is the genus for black locust, Robinia, and then Pseudoacacia because the leaves look like acacia trees. So it's a fake acacia is what it's saying.
And then so I guess this is like if it's Phalaenus robinia, it's like shelf locust shelf or something.
So that is what I had. I barely showed at the bottom. There was a tree joke in there. The sycamore was so there's there's the sycamore too. I didn't talk about it because I feel like we really know the sycamore a lot with the really exfoliating bark, showing out the white color. But my favorite thing about those trees and really trees in general is that when you're out in the forest, it's really difficult to get sycamore. Just little tree pens.
Well, Jay-Z has a great line about his parents like falling in love under the sycamore tree, which made him a more sicka MC. It's a great yeah.
Nice.
Yeah, sycamore more sicka.
And Tom chiming in on where even the Robinia name comes from, more originally from Jean Robin, a French botanist. Very cool. So I am definitely available for any questions anyone might have. A lot of these trees, pretty much most of these trees, we could see at the trip at Woodend if you are able to make it.
Awesome. Thank you so much, Bradley. You hit a lot of the questions I think as they came up in the chat. Does anyone want to jump on and ask questions? We can, if you raise your hand, we should be able to unmute you. I guess while we're waiting to see if people have questions, I'll ask a question. Do you know if, like, I know in Massachusetts, the beech trees seem to be a lot of this beech leaf disease. I've noticed they all look pretty messed up. And I was wondering, like, are you seeing that much at Woodend or around here?
So it's not present in the Mid-Atlantic yet, but I know the person who manages the natural areas of Longwood Gardens outside of Philadelphia, and she just reported that she has seen it starting there. So it's going to be interesting to see it progress into here. The diseases that we do have, of course, are the emerald ash borer, so it's hard to find mature ash trees. But I will say in Woodend, it's our #1 baby tree. So we'll see what happens in the future with our ashes because there are lots of little babies out there.
Are you guys doing anything, like, do you do anything to protect from like different nematodes or fungi or anything? Or
No, we do not. We also have eastern hemlocks. They surround one of our popular locations for where weddings occur when we rent out our property. But they're not a huge part of our ecosystem here. They're more important in the mountains. So we don't do any treatment on those. And I think it's difficult too, especially with the insects. You don't have there's not selective treatments that will only affect the bad one. The treatments will, if you were to inject an insecticide into an ash tree, it will kill any insect, native or not, that uses that tree. And we really don't support doing that. And trees will get replaced. Those trees will get replaced by something. And the dead wood that we leave is a very important part of the ecosystem as well. Do you give tree identification walks at other times of the year? Yes. I will put in a link to the Nature Forward events area. I'm leading another one at Woodend. So if you can't make the August 24th one, I'm leading another tree walk through Nature Forward at Woodend on August 16th. I'm doing a winter tree walk in December. And then as Tom he took a multiple week courses. I did a 10-week summer tree ID course and a 5-week winter tree ID course. And then in the spring of 2025, I'll be teaching botany. So I'll put that, let me grab that link. Christina, you asked a great question on planting additional trees, manage the proper. Do you rely on natural succession? I wish I could rely on natural succession. Unfortunately, being an urban area and side of the capital region, we had deer interrupting our ability to have natural succession. Deer removed any plant in the understory from native, non-native, as well as baby trees. Luckily, at Wood End, we were able to fence off a good portion of our property. So how do you cope with deer? We built a really big fence, and we herded them out. And we basically are consistently deer free, and have been since 2017. And that has allowed our forest to regenerate a little bit on its own, for helping it on the way there too. The fence is 8 to 10 feet. 8 were surrounding residential neighbors, 10 feet where it's along our roads. And we did have to get special permission for that solid fence in Montgomery County, but it works. And oh my goodness, we have so many really cool plants in the forest understory because of it.
I noticed you guys have a lot of mulch, along where the creek is. And is that from your trees, or is that mulch that's brought in, or what's the story with the mulch?
Typically, so it's both. So sometimes when we have tree companies take down trees on our property, let's say we do have to manage trees that are near our buildings and such, that if they're not doing well, we gotta get a tree company out. And if they end up mulching, we'll have them leave the mulch. And if sometimes when we really need mulch and we don't have tree work to be done on the property, we'll let the tree company that we use know, is like, hey, if you're in the area, you got a bucket of wood chips from a tree work you're doing nearby, you can drop them off here, which tree companies love to do because they have to pay to drop their wood chips off in other locations. So here's a link. Alan asked a question about the limited number of people on the August ID walk. I don't know what the MEWDC caps registration at for events.
Tom usually doesn't cap registration for the events that he makes, but he might be able to answer that question. Some of the events we do, because especially if they're on like smaller trails, but if you're comfortable with a bigger group, then
yeah, I think the only difficulty or thing that we have to keep in mind is at a certain group size, it can be very interesting to try to crowd around one plant. But otherwise, I'm very good at projecting, and the trails are flexible in terms of having larger group sizes. So I'm always amenable. If I do get more people, I might ask a coworker to help me out in just managing the group size, but that's fine. Do you grow mushroom beds in your woods? No, don't have any mushroom beds. I will say that it's
you have not on purpose mushroom beds, because all of those, there's a ton of mushrooms come up in those mulch beds. There's like not super interesting, but like a lot of different agrosophy species will come up in the spring. I've been looking for psilocybes, because sometimes those will come up in mulch, but I haven't seen them in Wood End yet. But who knows? Maybe they're coming.
Yeah, I still sometimes take pictures and we'll send them to Saranella, because I know she likes to see the fungi that's at Wood End. I do remember doing invasive removal a few years ago. And like I said, our forest is dominated by tulip tree. If you point at a tree at Wood End, 9 times out of 10, it's a tulip tree. And so we were doing invasive removal, and we found just like this huge patch of morels. It was really, really cool.
There is a really large tulip tree that looks like it might even be more than one tulip tree that like fused together. I don't know if you know what I mean.
Down by the pond?
Yes, yeah. What's up with that? How old is that? Yeah.
So that tulip tree, the stems that you see above ground now, it's a triple stem tulip tree. It is coming from one stump, but what that likely means is that tree 150 years ago, which is the age of the above ground stems now, 150 years ago, that tree was likely chopped down and used for its wood. And then it was allowed to grow back, and it grew back with 3 stems, because when trees start sprouting, they have a tough time deciding on who's going to be the main new stem. So sometimes you get like double or triple or even more sprouted stems coming from one single point. So that's where we got the triple trunk from. So if you can imagine, then the stump and the roots of that individual are likely well over 200 years old.
That's so cool. It's a really impressive, beautiful tree. Yeah.
Right. You can see that tree too, it spreads. Tulip trees really only will put leaves out where it has light. That tulip tree spreads in all directions. So you can imagine that that tree did not have any competition for light when it was growing 150 years ago, which tells us a little bit about what our property looked like 150 years ago. A lot of less trees, less forest, and that tree was growing in more of an open area without any light competition.
It doesn't seem, I have seen those hemlocks, which are so beautiful. It doesn't seem like they have the aphid. Like, do they have the aphid or
Yeah, they
they
do have
do?
the hemlock woolly adelgid. You can is
Oh,
you have to
intelligent.
look.
Intelligent. Sorry. Yeah.
Yeah, you have to look really closely on the underside of the stems. And it's just the little white on there. They do have them. They've had them for multiple years, and we've only like one or two have died, and they've had them for quite a while, and they seem to be doing okay. So, I mean, of course, we're worried long term, but I'm pretty excited to see they still produce fruit, or not fruit. They produce cones, not technically fruit. But so they do well despite.
Well, does anyone else? I think you covered a bunch of, oh yeah, here Elizabeth had a question. Have you planted any of the disease resistant trees or plants?
Oh, chestnuts. Disease resistance is relative. I've planted American chestnuts that are from the American Chestnut Foundation's decades long breeding program, where they bred the Chinese chestnut and the American chestnut, did tons of back crosses to get a tree that's 15th, 16th American, and 1/16th Chinese. And anytime we plant a whole bunch, and when the trees die, we get more. We just keep testing them to see how they do, hoping that there's enough resistance there. I had one tree, it's like 20 feet tall right now. It looks so good, but I'm just now seeing the first signs of blight on it. So it was really disappointing to see, but we'll see how long term, because the Chinese chestnuts, they do get the blight, but they're able to survive through it. So I'm curious to see what will happen to this really large chestnut tree right now.
What's your biggest non-native troublemaker tree wise?
Tree wise, Japanese maple. And the only reason is because it is tied to the history of our property. Our previous owner, who had the mansion built, was very into Japanese horticulture, planted a bunch of Japanese maples, which is all good. They're really pretty. But when you couple that with deer presence and deer not eating any Japanese maple seedlings and eating everything else that those Japanese maple would compete with in the forest, they became the only tree regenerating in the forest for many decades. So before I started managing them, our forest was made up of 25% of the stems were tulip tree, 25% of the stems were Japanese maple, and the remaining 50% were a variation of like 40 different species. I'm now down to Japanese maples only making up like 12% of the forest rather than 25. So still got a ways to go, but I'm getting at them. Norway maple and white mulberry would be next on the list. For invasive trees, I've got plenty of other invasives, plenty of other ones.
Is there controversy over taking trees out because
Yes.
native?
So the controversy primarily with the Japanese maples is the fall color. You know, it's really pretty. But when I take them out, I do leave the roots there, so they are acting as soil stabilization still. And I don't remove large patches of trees unless I have new trees and shrubs to put in immediately afterwards. So I don't just go in and remove a whole patch and leave it there, because then it'll just be a new invasive coming in. So I typically will plan my removals when I have plants to plant there directly after that. For the Japanese maples, I mean, they are pretty. I've got some really great pictures of them in the forest. But I keep telling people our native trees have great fall color too. They just come out at a different time. Yeah, so I've gotten the tree of heaven under control at Woodend. Um, the Atlantis altissima. I mean, our neighbors still have it. I can only do what I can at Woodend. Um, we have spotted lanternfly. We saw the first adults and last fall. I did some egg mass removals in the winter, and I'm seeing a couple of adults this year. I'm saying we have it. It's not a. I'm not saying it's a problem. It'll be interesting to see what that problem's like over time. But typically, when I'm finding them, because I don't have Tree of Heaven, when I look for them, I go find my grapevines in the forest, and they're typically right next to the grapevines. So when you don't have Tree of Heaven, that really their next second top thing they want to use is a grape. Choose one. Yeah. So any issues between the neighboring properties, including Rock Creek Park? It's tough because so the Rock Creek Park area, Montgomery County, they don't really do any vegetation management in those areas. So if we did like a really good removal, we're always going to, and it's even not just from the neighboring parks. We're surrounded by residential development, and people are always having, various plants. Those plants fruit, and those fruits can end up in Woodend. And in an urban area, you just have this endless sea of what I call propagule pressure, which is when we have new fruits of different species coming into the forest. And what I joke about when I say this is that this means that I will have job security because my job will never go away. There's always going to be something to manage. And so I don't say that it's like an issue. I think one thing that is encroaching on a large scale more and more is the wisteria. Yeah, they don't seem to have the recess. The invasive taking over. I just wish we would realize how much job creation opportunity there was in invasive plant management. How much? I mean, we'd have to put a lot of money into it, but I'm driving along the roads and there's just invasives lining at the side of our roads. I'm just like, we just like pay a whole bunch of people just to like do that all the time. We just have to get the money. And like I said, too, well, I haven't mentioned before, but I'm the only person who's in charge of the forest at Woodend. So it's a lot of work, and that's only 30 acres of forest. You imagine how much Montgomery County has to deal with. Montgomery County is not small. My workers used to play spot the invasives. That's a thing I have trouble with. It's hard for me to turn that filter off when I'm on walks. So I'm just trying to enjoy myself on a hike. It's really challenging to turn off. So once you cure your plant blindness, it's cured. You're not going back.
Maybe if you start learning the mushrooms, it'll distract you.
Yeah, I guess so, right? Be distracted by trying to learn something new. I mean, it's true. That would help.
Folks, have any other questions? Speak now.
Thank you, Bradley, for your patience with all of our questions and all of your wonderful slides. I'm definitely going to be watching this again because it was like really rich with stuff I want to be able to remember.
Yeah, definitely. It's a lot. It's like I said, it's its own language. I'm sure y'all are familiar with that, with the terminology around fungal identification. It really is just learning the terms and learning what to look for. So I put my email in the chat so it's there. I know Tom has it. And the PowerPoint slides have been shared as well, so you can always have those as a reference. But I think always get like the little books to have with you when you're on the field. Always good to have like a little book.
Yes, I am sure everyone will be very happy that this one was being recorded. We will get that up on YouTube as soon as we can. Thank you so much for your time tonight, Bradley, and for everyone that came out for the meeting. This has been great.
Thank you, and looking forward to your walk. So that should be
Yeah,
great. Take care.
great.
And
you.
everybody take a look at again at the events page, because there's a lot of stuff coming up through MA and also through Mount Rainier Nature Center. So hope to see you out there. All right, good night, everybody.
Thanks. Very interesting. Have a good one.
Bye-bye.